introduction to machine learning. I believe that my previous lecture helpful for you. This is the very beginning of machine learning. Actually, this is a vast field, and it is much more than what we thought. It's a very small, very brief, just introduction to machine learning with very small. Let me introduce this thing. See, artificial intelligence, that is AI, it is and machine learning, both are very much interrelated to each other. So first we will go for what is the AI. Artificial intelligence is a huge topic today. That is what I'm talking there. And it is getting bigger all the time thanks to the success of technology such as Siri. I'm taking example of Apple Siri. Talking to your smartphone is both fun and helpful. These are very small things to find out things like the location, the best sushi restaurant in town, or to discover how to get to the concert hall. As you talk to your smartphone, it learns more about the way you talk and makes fewer mistakes in understanding your request. That is what it's learning. The capability of a smartphone to learn and interpret your particular way of speaking is an example of an AI. And part of the technology used to make it happen is machine learning. That is what our basic topic. You likely make limited use of machine learning and AI all over the place today without really thinking about it. Let me say, for example, the capability to speak to devices and have them actually do what you intended is an example of machine learning and work. It's very basic way. Likewise, recommender systems such as those found on Amazon help you make purchase based on criteria such as previous product purchase or product that complement a current choice. The use of both AI and machine learning will only increase with time. That is a story. That is AI. Machine learning is another part of it. AI is different, have moved fast, but AI having machine learning. You may also have heard machine learning and AI use interchangeably. That is, it's a, for a beginning you just say they are the same things. For very first basic way, won't go in details. AI includes machine learning, but machine learning doesn't fully define AI. Machine learning and AI both have a strong engineering component. That is, you can quantify both technologies precisely based on theory, substantiated and tested explanation, rather than simply hypothesis, a suggested explanation for a phenomenon. In addition, both have a strong science components through which people test concepts and create new ideas of how expressing the thought process might be possible. Finally, machine learning also has an artistic component, and this is where talented scientists can excel because you have a lot of stuff to do there. You can make what lot of things to be learned by machine using different kind of algorithm and different stuff. In some cases, AI machine learning both seemingly defy logic, and only the true artists can make them work as expected. AI is built on the hypothesis that mechanizing thought is possible. During the first millennium, they are talking about first millennium, Greek, Indian, and Chinese philosophers all worked on a way to perform this task. As early as the 17th century, Gottfried Leibniz, Thomas Hobbes, and René Descartes discussed the potential for rationalizing all thought as simply math symbols. Of course, the complexity of the problem eluded them. The point is that the vision for AI has been around for an incredibly long time. It's not a new thing. It's a very long time here. But the implementation of AI is relatively new. Thing is that we know something there, but it is right now implemented. The true birth of AI as we know it today began with Alan Turing during the publication of Computing, Machinery and Intelligence in 1950. In this paper, Turing explored the idea of how to determine whether a machine can think. Of course, this paper led to the imitation game involving three players. Player A is a computer and player B is a human. Each must convince player C, a human who can't see either player A or player B, that they are human. If player C can't determine who is human and who is not a consistent basis, the computer wins. It's a basic idea and it can implemented there. Exploring what machine learning can do for AI. Right now we are talking perspective of artificial. intelligence. Machine learning relies on algorithm to analyze huge data sets. Currently, machine learning can't provide the sort of AI that movies present. You see a lot of movies there, they have certain things which actually thrill you. Even the best algorithm can't think, feel, present any form of self-awareness or exercise retrieval. What machine learning can do is perform predictive analytics for faster than a human can. As a result, machine learning can help humans work more efficiently. This is one of the basic necessity today. The current state of AI then is one of the performing analysis, but human must still consider the implication of that analysis, making the required moral and ethical decisions. The considering the relationship between AI and machine learning, actually this is I'm taking from the dwells mode. It's actually dwells mode. You have a lot of things there. The essence of the matter is that machine learning provides just the learning part of it, and that part is nowhere near ready to create an AI for the other sort you see in the films. It's right now in that stage that whatever we have seen in films, like there's so many films come over there, AI related films, we are able to do it actually in actual life. What are the goals of considering them? At present, AI based machine learning, and machine learning is essentially different from statics. Yes, machine learning has a statistical basis, but it makes some different assumptions that statistics do because the goals are different. Let comparing machine learning to statistics. Data handling work with big data in the form of networks and graphics. Raw data from sensors or the web text is split into training and test data. While statistics models are used to create predictive power on a small sample. Data input. The data is sampled, randomized, and transformed to maximize accuracy. So, scoring the prediction of out of sample or completely new example. Parameter interpret real world phenomena and provide a stress on magnitude. Result. Probability is taken into account for comparing what could be the best guess of the decision. The output captures the variability and uncertainty of parameters. Assumption. The scientists learn from the data. The scientists assume a certain output and they tries to prove it. Distribution. The distributions are known or before learning from data. The scientists assume a well-defined distribution. In statistics, fitting. The scientist creates a best fit but generalizable model. The result is fit to the present data distribution. So statistics and you see they have been very well different from both of them. They have different lines. Machine learning defining how, on the basis of hardware limits. Huge data sets require huge amount of memory. Unfortunately, the requirements don't end there. When you have huge amount of data and memory, you must also have processors with multiple cores and high speeds. One of the problems that scientists are striving to solve is how to use existing hardware more efficiently. In some cases, writing for days to obtain result to a machine learning problem simply is not possible. The scientists who want to know the answer need it quickly, even if the result is not quite right. That is what basically the power of learning machine learning. You don't need to have a right answer always. You need an answer there. With this in mind, investment in better hardware also require investment in better size. Why do we need these all kind of things? We can have obtaining a useful result, asking the right decision, and relying on institution to have it. That is to there because learning is something which be correct, which should be correct, has to tend to be in the right direction. So institutions are very important. When you begin to realize the importance of environment to machine learning, you can also begin to understand the need for the right hardware and the right balance to obtain a desired result. The current state of the art system actually rely on the graphical processing unit (GPUs), as you know, to perform machine learning tasks. Relying on GPU does speed the machine learning process considerably. I think it's very brief, but I think it will help you. If any case, let me inform you.